So first of all, good morning, everybody. I hope you guys are enjoying this conference so far. My name is Cheng. I'm the Vice President of Data Science from .data. Before I begin, I want to thank you for coming to my presentation and joining me discussing this very important topic. I do have prepared quite a bit of materials today, so let's see how much I can actually get to cover. And also, during the past few months, I've had the opportunity to talk with many customers about their data science practice in each different industry. So from that perspective, I want to take today's opportunity to incorporate those feedback and share them with you. So what I would like to do today is I want to start this presentation by making a statement. That statement is that the data science is now become the core to many business. I don't think there is any objection to this statement in today's audience. You know, we are gathered here today from all different industries in the United States to discuss data science, practice really speaks to the truth of this statement. Speaking of myself, before I became the Vice President of Data Science at .data, and previously I was managing Accenture's data science practice, specifically on the West Coast. So from that job, I really learned first-handedly how important data science has become to many industries, really to all the industries, based on what I have seen. I remember that I was invited to the Chief Marketing Office in San Francisco for one of the largest clothing retailers in the United States to discuss with him how we should be looking at his data, how we should be using the machine learning technologies to analyze the data, so to help him to drive up the online sales performance. It's a very real use case for him. And also, I was personally leading a very large infrastructure data science project at the largest social media company in the world in Menlo Park, California, to help them analyze their infrastructure data, so to improve the data center operation efficiency and reduce the downtime. And on the current job with .data, I'm very privileged to be working with one of the top 15 financial institutions in the world to look at their customer data, to use our tool to analyze their customer data to understand the customer behavior, which enable them to come up with more ideas to develop better products and come up with a lot of better programs to target the customers that they're interested in. I think all in all, if there's one thing that I have no doubt about in this past 13 years of being in this data science business, it is that the impact of data science to today's business is real. It's very significant. It's something that no business leaders can afford to miss. Then, on the other hand, we must acknowledge that data science is very difficult. Data science is not an easy subject. There's many different reports coming up talking about the numbers. So last year, Gartner's report is 85% of a data science project will fail. So this one is actually coming from Dimension Research. It says 96% of the organizations run into issues with the data science machine learning type of initiatives. So what this means is only 4% of the company have successfully incorporated data science and machine learning into the core part of the business. And to nobody's surprise, this 4% of the companies are Googles and Amazons of the world, right? And also, I don't believe there's any doubt that to these companies, without machine learning, without data science, they could have achieved what they have achieved, or they could have become who they are today. From the past 10 years of short history, that's really the power of machine learning and data science. But meanwhile, if we look at this number, right, 96% of the company, this is the vast majority of the companies we are talking about. And for this 96% of the company, a lot of them, they probably have not even started. They just started talking about data science, but they have not really started anything real in terms of collecting the data, discussing the use case, discussing technology stack, discussing how they should be visualizing the data, how they should be running the production on those data. They have no idea. And then there is a significant amount of companies that I personally have interacted with as well. They have started. They have brought a few data scientists. They try their best to hire data scientists. They have probably planned for some data science projects, maybe even data science products, but they are nowhere close to harvesting the business impact that data science has promised them, right? So they are really struggling. They are constantly struggling about the multiple issues. Is this the right data? Do we have enough data? What is the right technology infrastructure we should be investing in? Should we be doing Python? Should we be doing R? Should we be doing SaaS? Should we be doing all those different kind of platforms, right? So there's many real issues these companies, they are trying to figure out. But the key is that data science is not very easy. Then let me explain to you, from my experience, why data science is not easy, right? So there is a variety of reasons. The first one, in my view, is the technology and the knowledge base that is required to support data science, to execute data science is very complex, it's very broad, and most importantly, it is fast evolving. Think about it, 15 years ago, nobody has conceived that we are accumulating this much data as what we are doing today. And the other great example is a deep learning neural network. A few decades ago, when this idea was brought up, was proposed, it was perceived as a paper exercise because the amount of computational resources it requires to execute, to support that algorithm was beyond physical limitation just a few short decades ago. But today, deep learning neural network has become the business norm in many different industries. So that's the world that we live in. Everything is moving very fast. I think the issue here is the fast evolving nature of this business, or fast evolving nature of this data science field has made it close to impossible for any single organization, any single team, or any single data scientist to be capable of managing this data science projects from an end-to-end perspective. And we all have worked at large companies at some point in our past career. We all understand that working across teams is never as easy as it sounds, right? So that's the first part. Second part is data scientists today is still a very scarce resource. It's what is it? Oh. The data scientist today, it's still a very scarce resource. Right? A lot of people are here looking for data science job. Last year in October, LinkedIn actually published a report. At that point of time, there was 141,000 data science job vacancies in the United States. 141,000. So data scientists are very, very difficult to hire. There was a lot of demand, but there's not enough supply in the job market. That is simple truth. And the last one is the data science process is a complex process. We all understand data science is more than just building machine learning models. If data science is as simple as applying machine learning models, then all the problems will be solved. We understand data science actually starts with defining a business problem. Then you have to collect data. Then you have to go through the data journey, cleansing the data, preparing the data. All of that work is very manual. And after that, you need to go through a process called feature engineering to generate a feature hypothesis coming out from the source data. So to make the source data ready for machine learning. This feature engineering process, as we understand it, takes a lot of effort talking with the domain experts. Right? It's a very interactive process. And also building machine learning models, we understand requires statistician, requires mathematician, data scientists with enough technical knowledge to do that. And then visualization. Right? You build a model. Nowadays, a model is much more than linear regression. Right? Linear regression, we all understand it. But when you're talking about the deep learning neural network, when you're talking about XGB boosting, right, what is the easier way to help you understand the model? Right? That's why you need visualization tools to help you understand the model. Right? And the last part, which is also very important, which is the productionization. Right? You build a model on your Jupyter notebook doesn't mean anything because nobody can use it. That model needs to go to some part of your business process so that someone can run it on a daily basis or weekly basis to generate results. That result can benefit the business team. That's the productionization part of data science. It's not very easy. It's not very easy. So this entire process, as we just talked about, is very complex. There's many different components, involve people with very different skill sets, right? Data engineering, database, people with database skills, people with data engineering skills, statistician, mathematician, and also computer science skills. We all know it. Software engineering and also software architectural type of knowledge. All of this knowledge is actually required in order to deliver one single data science project. That's how complicated it is. If we are really talking about enterprise data science, this is how complicated it is. And now, I want to tell you automation will change data science. And at the end of the presentation, I will show you specifically what automation will do for a real data science use case. So first of all, let me explain to you why I think automation will change data science. And there is 4 pillars to the data science automation. So they are acceleration, democratization, augmentation, and operationalization. So let me explain this one by one. The first one is acceleration. So what does this mean? As I explained to you earlier, data science project typically takes a long time because the process is complex. The reason that takes a long time is first of all, there is a lot of manual work that is required. Someone needs to manually code up all the data engineering pipelines. Someone needs to manually code up all the data quality check rules. And someone needs to manually call the Python library in order to use some of the open source models. So those are all manual process. The other part of it, it's very iterative. You need to talk to domain expert. You need to talk to people who've done this before to get their opinion. And we understand, people have different experience. They may have very different opinions. That's why this process becomes very iterative. But if we apply data science automation, it becomes a little bit different because automation tools, basically, it will run through all different hypotheses. It will go through all different combinations possible to come up with the best algorithm, to come up with the best data engineering process in order to help you build the best model. So from that perspective, with automation technology, we can iterate more. We can do a lot more. We can try many, many more rounds and deliver results a lot faster. And the next aspect is democratization. I also explained earlier, because data science project is very complex. It involves people with different type of skill sets. Business analysts, data engineers, people with a lot of statistics, mathematics, computer science, software architecture type of knowledge, right? So you need people with very different set of skills in order to participate, in order to contribute to the data science project. But with automation, because automation will do a lot of heavy lifting behind the scenes. It will do a lot of the manual work for you instead of you have to do it by yourself. Automation will take care of that. So with this, we can really enable more people to participate in this process. Maybe the business analyst, they can run machine learning models, even though this business analyst does not know exactly what is the mathematical mechanism in doing those exercises, but this automation solution can do that for them. So you can get them started. So that's a point here, which is we call democratization. Enable more people to participate, to contribute. And the next component is augmentation, right? As I said earlier, the typical data science process involves a lot of conversation with the domain experts. And domain experts, I have tremendous respect for domain experts. I work a lot with them, but I also understand the domain experts, a lot of times, they are only as good as their last mistake. So by talking with them, by relying on their input to get started with a data science project, we are somewhat limited by what we have already known. Later on, I will show you some case study. Oftentimes when we are presented with an enterprise data set, talking with the domain expert simply means ignoring a big part of it because we don't know enough. Right? Domain expert doesn't have enough knowledge about that data, so what you do, ignore them. So that's a process. But with automation, it's different. Automation basically will look at the data in a very unbiased, in a very impartial approach because it's a machine. You cannot differentiate column A and column B. It will just go through all of them one by one. Run through all the combinations, run through all possible scenarios to analyze them in order to come up with the best feature representation to build the model. So from that perspective, automation can actually extract a lot more information that was not known to us before. Automation can come up with a lot of insights. I'm not saying they're the universal truths, but they are some kind of data patterns, very deeply embedded data patterns that can be discovered, which was not known to the subject matter expert. So that's another dimension of why automation is a good solution. When we are trying to augment the manual approach, we can take this new insights, new data patterns extracted from the automation solution and apply that to whatever we are doing right now manually, combine them in order to build the best machine learning model. And the last part is operationalization, right? So this one is actually critically important. A lot of times we all understand, especially having worked in very large companies before, right? Data science project is a big success on the data scientist's Jupyter notebook. But when they go to production, it becomes a failure, right? The code cannot be easily merged because the code is not thoroughly tested. Second of all, the code cannot be merged. Maybe the code is not a software quality code at all, right? So when we come to operationalization of data science project, there is a lot more than just building models. There is a lot more than just building models. So this is where automation can really help, because when we are running when we are using the automation solution behind the scene for all the models that the automation solution is explored, we are automatically generating software-grade code. It's not a manual code. It's not a manual data scientist code. And those code, oftentimes, is wrapped by some API, which can be directly deployed. Instead of data scientists manually code some code, needs to go through all kind of testing, needs to go through all kind of hurdles, and in the end, it still have all kind of issues. But automatically generated machine learning code wrapped by API is actually very, very easy to be deployed. So that's where the automation becomes very, very important, in terms of helping with data science operationalization. So these are the 4 pillars, the 4 aspects where automation can really help. One is acceleration, the second one is the democratization, the third one, what is it? Augmentation, and the last one is operationalization. All right, so the last part, I'm going to talk a little bit about the company.data, and now I want to show you a very quick use case of how we can use the automation solution to solve a very specific problem. So the company I represent for .data, we are based out of the San Francisco Bay Area in a town called San Mateo. It's about 5 miles south of San Francisco International Airport. So we were recently named as a leader in the Forrester New Wave. So Forrester is one of the largest market research companies in the world. So they named us a leader in this automated machine learning space because they believe that the feature engineering technology that we have developed is really powerful. It can really help the customers to analyze the data from a very different perspective, to extract more information, to extract a lot of information that was not even known to them before. And this slide best explains what is automation doing to the data science, traditional data science process. So this is a traditional data science process. I believe I just briefly explained it. There is a business problem identification. Then you have to collect the data, you have to wrangle the data, prep the data. Then you need to go through the feature engineering process. Feature engineering process, it's a process of combining data from different sources, bring them together, generating the feature representations, and then building machine learning models, going through the visualization step to help you understand the models, understand the features. And sometimes there's a feedback loop in this process as well, and then put the whole thing into production. This entire process takes many steps, takes many different resources with different type of expertise to complete. But with our automation solution, as you can see, we can shrink this entire process into something much, much smaller. Oftentimes for a project that would take a few months to complete, in our case, it's a matter of a few days. Because as I explained earlier, the heavy lifting, the manual work is being automated. The manual work is being automated. So specifically inside our solution, there's a few core components. The first one is called AI-powered feature engineering, which I will explain very briefly later on. So this AI-powered feature engineering technology will basically take care of this entire process. Then we have automated machine learning. So this one will basically automatically go through a list of machine learning algorithms to identify the best algorithm, the best hyperparameter for the algorithm. And then we also have the .data GUI, which supports all kind of visualization that customers are interested in, and also the API. Our machine learning models are wrapped by API. By calling that API, you can easily deploy it. Then lastly, let me do this case study very quick. Okay. So the case study here say we want to solve a problem. What is the problem we want to solve, right? Going back to this process. First of all, we want to identify a problem. The problem is for a large bank, I want to identify, I have a lot of retail customers, saving, checking, whatever it is. So my problem is I want to analyze all the customer behavior so to identify the customer that I can promote my new product to, which is a mortgage product. Then if this is the case, this is the data that I can possibly find. Right? There is some mortgage application information, which was historical information about who's applied, who's not. Then you have CRM data, customer attributes. All the customers the bank is at, it's in this table. Then you have account master, all the account information related to customer. Then web transaction information. And then there's a balance history information. There's a store master information, maybe some geolocational information. So this is the data we have, right? As you can see, data is not in one table. Data is distributed across different databases. Then the challenge is, okay, with this, how can we run machine learning models? We all know that this data as a cell, as it stands right now, cannot be directly consumed by any machine learning models. So we need to go through this process of which we call feature engineering, right? Which is the process of processing the source data and then take the source data, generating what we call the feature representation. This can be fairly complex. Like in this case, some feature can be like someone that withdraws a lot of money for the past half a year, and occupation is an engineer. So this can be the type of feature representation we are talking about. And if you look at this feature carefully, this feature is not coming from any single source table. Right? If you go to any of the single source table, the feature is not an attribute in any one of them. The feature is actually a combined and aggregated information coming out from a few source tables. Like in this case, it's information that is coming from these 4 tables. So in order to generate this single feature, there is a lot of SQL exercise that is required. But that's not the only challenge. The bigger challenge is that when you have a data like this, with this many information, you have 6 tables, you have 500 columns. For this type of data, how many feature hypotheses are we talking about? How many feature hypotheses do you think the domain expert is ready now? Typically, when you have more table, when the data is getting crazier, you need a lot more feature hypotheses. So without using this type of automation solution, we are really just doing whatever the domain experts tells us. Because it's so complex, right? So that's feature 1. Someone withdraws a lot of money for the past year. Occupation is engineer. You can be talking about the next feature. Someone spends a lot of time on the web for the past 3 weeks and receives direct email campaign. You can keep on going. Typically you need hundreds to even thousands of feature hypotheses. Then where is that brain? Who can provide the information? Who can provide what feature hypothesis to be looked at, right? So this is the challenge. This is where the automated feature engineering becomes very important because it will automatically explore the data, coming up, extracting the information, coming up with the relevant feature hypothesis, which can be used to generate the model. The last slide is, so this one is fairly straightforward. Why do we need automated machine learning, right? Because for a single problem, for example, for a single classification problem, there's many different type of algorithms one would want to try. Right? And for each algorithm, there's many different hyperparameters. There's different processes that is required. And also, this one is also very important, parallelization. Because nowadays, for the data we are looking at, it's typically very big. And some algorithms, they take a very long time to execute. If you run them sequentially, it will take forever to get results. That's why you need to parallelize them. Then parallelizing these machine learning algorithms, given that some of them are coming from one library, another one from a different library, there's a lot of hassles that you need to go through in order to parallelize them. So those are all the great challenges we have when we are talking about automating machine learning. But with automation solution, all of this can be taken care of. So I think I'm going to stop here. I have minus 4 minutes now. So there is a lot more that I can talk about. But again, I think the point of this discussion with you guys today is I want to introduce this automation concept, data science automation concept to you, so that when you go back to your daily life, you can think about it, if this is something that is relevant to your needs. If that's the case, feel free to go to our website and get information and shoot us an email if there's any interest. That's all. Thank you.